Hello there and welcome to a brand new lesson. This is Have Beyond Numbers where we learn maths the easy way. In this lesson, we are looking at question 9 of WASSCE 2026 General Mathematics Paper 2. It is on movie ticket sales. By the end of this lesson, you should be able to set up an equation involving ticket price and number of tickets sold. You should be able to use the relationship to solve for total receipts. You should be able to form and solve quadratic equations from word problems. And finally, you should be able to interpret the solution in the context of the problem. On our left-hand side are solutions to the trial exercises I gave on our previous lesson. That is on question 8. If you have not looked at it, you can also look at the playlist where we have all solutions to the various questions. That one was an interesting one, of course, on the earth as a globe. Without much I say or do, let's quickly look into this. So that's the question. It says, on a certain day, two shows of a movie premiere were aired. The cost of tickets for the first show was X cedis each. And the total receipts from the tickets was what? 45,000 cedis. In the second show, the price of each ticket was reduced by 5 cedis, resulting in 300 more tickets being sold. This increased the total receipt by 9,000 cedis. We have to find A, the price of the ticket for the first show, and then secondly, the number of tickets sold in the first show. This is a very, very interesting scenario. Now, the key concept you are supposed to know in order to solve this question is this. First of all, the revenue is simply the price times the number of tickets that were sold. They will be making use of substitutions to solve for the unknowns. So let's solve. Now, since we are going to make use of some variables, let's define our variables. So we say, let the number of tickets sold in the first show be any variable at all. Now, if n tickets were sold, then it simply implies that the revenue that was made. So let's just call that revenue at the first show. The first show, we are going to name it A. So revenue at A is simply going to be n times x, because we know the cost of each ticket is x. So this is the revenue at the first show. Now, even from the statement, we're given the revenue. So we know the revenue for the first show was 41,000. If you want to substitute that here, it simply means we have a 45,000 was a 45,000. So if you want to substitute that here, we have 45,000, which is equal to the number of tickets that were sold times the price of each. So we are going to let this be our equation 1. Now it says in the second show, the price of each ticket was reduced by 5 cedis. So it simply means that the new price for the second show, so the price of ticket for second show, since there's a reduction, it is going to be what? X minus 5. You see, now this x minus 5 we are talking about, they said it resulted in 300 tickets more being sold. You see, before we even proceed, right here we can determine how many tickets were sold. That is making n the subject. It simply means we have our n, which is equal to 4,500, 45,000 divided by x. So for the first show, this is the n that was sold out. But in the second one, they said 300 more. So if 300 more, it simply means 300 more than the previous one, which is what? a 45,000 all over x plus 300. So these were the number of tickets that were sold for the second one. And what happens? It increased the total revenue or receipts by 900. It increased it by that. This isn't the new one, but then it increased it by that. They are not saying this is the revenue. They are rather saying that it has increased the revenue by this amount. So the revenue for the second show, which I would name RB, is going to be the initial one, which is our 45,000, plus the increase we have here, which is the 9,000 DC. And when we evaluate that, we have a 54,000 cedis, right? So this is the revenue for the second one. We have all we need to now solve the question. We have said that the revenue is simply equal to what? The price times the number of tickets that were sold. This is the total revenue for the second one, you see. And it is equal to the price. What is the price? This is the price. You see, so the price of a ticket for the second show, we said it was reduced by 5. That is how come we have this x minus 5. So the revenue is equal to this price times the number of tickets. This is the number of tickets which we evaluated to be this. So let's do the necessary substitution here. Revenue equals price times number of tickets. So our revenue, which we have over here, which is our 54,000, is equal to the price, which is n, which is x minus 5, and then times the number of tickets. There's the number of tickets that were sold. So we have 45,000 over x plus 300. Take note, it is multiplication, and hence we need our brackets so that we don't get confused. How do we evaluate this to solve for x? Now, the first thing we need to do is to expand. So expanding, we still maintain 54,000 right here, and that is equal to, this is going to multiply this first term, and then it's also going to multiply this second term. So we have x minus 5 multiplying 45,000 over x, then plus x minus 5 also multiplying the 300 we have here. So we have our 54,000 equal to x times x multiplies this whole term we have over here. So that we have x times 45,000 all over x. Then the negative 5 also does the same. So negative 5 times the 45,000 all over x. Then you come to your plus, and then x multiplies 300 to give us x times 300. And then negative 5 also multiplies the 300. So with what we have here, we then write our 45,000, which is equal to, this x cancels out to this x, and we'll be left with the 45,000, then minus 5 multiplies 45,000 all over x to give us a 225,000 all over x. Then we have x times 300, which is a positive 300x, negative 5 times 300 as well, which also gives us a negative 1,500. We now simplify and then solve. So we keep our 54,000 right here. And then since these are like terms, we then arrange and then evaluate them. So we have our 45,000 minus 1,500, then minus, let me just bring that here. So minus 250,000 over x plus 300x. So we still have 54,000 equals 45,000 minus 1,500 gives us a 43,500. We then have our minus 225,000 over x and then plus 300x. We can then choose to bring this to the left hand side, so that we have 54,000 minus 43,500, and that is equal to a negative 225,000 over x plus a 300x. Simplifying what we have on the left hand side, we are going to get a 10,500, which is equal to the negative 225,000 all over x and then plus 300x. Now, since there's a fraction involved, what we'll do is we'll multiply each and every term by x, so that we eliminate this x over here. With that, we have a 10,500 times x equals negative 225,000 over x times x plus the 300x times x. And with that, we'll get a 10,500 x. Then this x here cancels out this x. So we'll be left with a negative 225,000 and then plus the 300x times x, which gives us a 300x squared. If you are to rearrange what we have here, we would get a 300x squared. That is keeping it here. And then we bring this to the right hand side, so that it gives us, or to make the explanation simpler, we still have 0 here equals, so we are moving everything to the right hand side. Moving everything to the right hand side, we have negative 225,000 plus 300x squared and then minus 10,500 x. This looks like a quadratic expression, you see. And for quadratic, we know it is written as a x squared plus b x plus c is equal to 0. So we are going to model this that way, so that we have a 300x squared minus a 10,500 x and then minus a 225,000 is equal to 0. Since the numbers are very, very big, we can choose to simplify. And how do we simplify? We just divide each and every term by 300. So if I'm to divide this by 300, this by 300, and then this as well by 300, what happens? This 300 cancels out this 300. This 2 zeros cancel out these 2 zeros. These 2 zeros as well cancel out these 2 zeros. So we have x squared, then 3 into 105, how many times? That is a 35 times. So we have 35x. And then 3 divides 2,000 250. How many times? That is a 750 times, and it's equal to 0. So this here is our quadratic. The easiest way to solve is by using the almighty formula, which says our x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. The reason being that we don't have any common factor, hence we just have to use the completing of square or the almighty formula. So our x is then equal to negative b. This here becomes the value of b, and then a is the coefficient we have here, which is 1, and then this is the c. So doing our substitution, we have x equals negative b, so the negation of our b, which is negative 35, plus or minus the square root of b squared, so that becomes the negative 35 squared minus 4 times our a, which is 1, and then times the c, which is negative 750, all over 2a. The value of a is 1, so 2 times 1 gives us 2. Our x is then equal to negative times negative 35 gives us a 35. Then we have our plus or minus the square root of negative 200 and negative 35 squared gives us a 1225. Then evaluating negative 4 times 1 times negative 750, we have a positive 300, that is positive 3000 all over 2. We then simplify further, so we have our x, which is equal to our 35 remains, then plus or minus 1225 plus 3000 gives us a 4225, not forgetting the square root, all over 2. So our x is then equal to the 35 plus or minus the square root of 4225 gives us a 65. So 65 all over 2. This simply means there are two possible solutions, the one for the positive and then the one for the negative. So that of the positive, we have x is equal to 35 plus 65 all over 2. Our x is then equal to 35 plus 65 gives us 100. So we have 100 over 2, and then our x is equal to 50. And for that of the negative, we have our x, which is equal to 35 minus 65 all over 2. And 35 minus 65 simply gives us a negative 30. So we have x, which is then equal to a negative 15. But remember, what are we solving for? All that we've been doing so far, we are actually solving for the price. Remember, the x is the price, and price cannot be negative. You see, price cannot be negative. So we can conclude by saying, therefore, the price of a ticket for the show is what? The 50 cedis. As simple as that. It was long, but I think if you pay attention to this during your exam, you'd be able to do it. It is just to test how well you can pay attention and then order your steps, because these are all basic mathematical concepts that I'm sure you do understand. Let's look at the second question. And for the next question, it says we have to find the number of tickets sold in the first show. The number of tickets sold in the first show. Remember, I used n to represent that here. So we said, let the number of tickets sold be what? N. And later on Upon making n the subject, we have n being equal to what? The 45,000 all over x. We have now solved for that x, so we can do our evaluation. So we say the number of tickets sold, that is n, per our subject that we wrote, or per our change of subject, we had 4,500, that is 45,000 over x, and our x is simply the 50. Hence our n is what? The 45,000 all over the 50. And simplifying this gives us a 900. So we can conclude by saying, therefore, the number of tickets sold in the first show was what? 900. Or simply put, therefore 900 tickets were sold. So that ends this question. And as usual, I'll leave with some exercises so you try on your own to test your understanding on what we've done. So here are 5 questions based on what we've just done. And you can pause the video and attempt before moving to question on the playlist. This is How Beyond Numbers, where we learn maths the easy way. If there's any issue of concern, you can always let me know at the comment section. And when notified, I will address that for you. If this is your first time as well and you think this channel will be of help to you, you can check the homepage where I have lessons on various topics, complete set on junior high school and then ongoing ones as well on senior high school, both core maths and then e-maths. See you in our next lesson, and bye for now. Do stay safe.